This is Ham College, episode 107, for December 1st, 2023. Ham College is brought to you by ICOM. Searching for the perfect holiday gift? This holiday season, make your gatherings merrier, your message clearer, and your connection stronger with ICOM. Hi, welcome to another class with Ham College. I'm Professor Thomas.
And I'm Dean Martin.
And we've got some extra questions for you tonight. And that's a play on words because it is the extra exam, but there's more questions.
But there's some extra questions.
Extra questions this time around.
Yep.
What did we talk about in the last episode?
Well, let's see. Since I didn't bring my thing, I believe we talked about antenna patterns in design, E9C
Plane patterns.
Yeah. Yep, that's what.
Just look at my thing.
Yeah, your printing's better than my handwriting. Gain is a function of pattern and antenna modeling.
This month we're going to talk about practical wire antennas, folded dipoles, phased arrays, and effects of ground near antennas. What is the radiation pattern of two quarter wavelength vertical antennas spaced 1/2 wavelength apart and fed 180 degrees out of phase? Is it A, cardioid?
B, omnidirectional?
C, a figure 8 broadside to the axis of the array?
Or D, a figure 8 oriented along the axis of the array? What is the radiation pattern of two quarter wavelength vertical antennas spaced a 1/2 wavelength apart and fed 180 degrees out of phase?
They don't get any easier either.
Yeah, I know. I glanced at the questions. I didn't glance at the answers, so it'd be kind of boring if you knew all the answers. I guess it would. The figure 8 to the broadside. I don't think it's cardioid. I'm gonna go with C. I really don't know.
Well, let's see. The chat room is saying C and D and EC.
E.
Yeah, and a lot of them not saying anything.
Yeah, E. I'm going with E.
Oh.
Yep. That's first buzzer. There'll be some more.
A single quarter wavelength vertical antenna would have a pattern like this, viewed from the top.
Top down.
Yeah, it's the same all the way around. No difference. Two verticals spaced a 1/2 wavelength apart, fed in phase. So there's no phase shift between them.
Yeah.
That's what it would look like.
Yeah.
Two quarter wave verticals spread a 1/2 wavelength apart, fed 180 degrees out of phase. And this is the case we were just talking about. It's figure 8, but it's along the axis of the antenna array. You got one for me?
I sure do. I hope it's a good one.
Oh, you know it will be.
What is the radiation pattern of two quarter wavelength vertical antennas spaced 1/4 wavelength apart and fed 90 degrees out of phase? A, cardioid.
B, a figure 8 end fed along the axis of the array.
C, a figure 8 broadside to the axis of the array.
Or D, omnidirectional. So let me think about that. What is the radiation pattern? Two quarter wave vertical antennas spaced a quarter wavelength apart and fed 90 degrees out of phase. I think the right one is C, a figure 8 broadside to the axis of the array.
Did your final answer?
Yeah, it's probably wrong, but
God, I hope so.
what are the...
Not that I wish you
Oh, they're all saying A over there.
Are they?
They are, and it could be. Yeah, they're probably right. I think they are. I think it is A, but I already said the wrong answer.
Yeah, we haven't revealed it yet. But you cheated with the chat room, so.
Yep, that's the same as looking right there. I'm gonna go with C, but I think it's probably A. There we go. Boy, it's a
Right.
tie ball game.
Yeah, it is.
Everybody's losing at this point. So, a cardioid pattern. I drew that. I should remember it. 2/4 wavelength vertical antennas spaced a quarter wavelength apart, fed 90 degrees out of phase. What is the radiation pattern of two 1/4 wavelength vertical antennas spaced 1/2 wavelength apart and fed in phase? A, omnidirectional.
B, cardioid.
C, a figure eight broadside of the axis of the array.
Or D, a figure eight in fire along the axis of the array. I'm probably wrong. I don't know how to interpret that picture if I'm remembering the right one in the book. I want to say it's more A, omnidirectional, but I think the answer is probably going to be C. Because the antennas were like this, but it was more like an oval.
So you're saying it's A, but you think it's C?
I'm saying it's C, but I really think it's probably closer to A.
Well,
It's not omni.
You got to pick one or the other.
I'm going to go with C.
Okay. That's what they're saying over in the chat room. Well, Marty changed to A. I'm going to go with you. I'm going to say it's C. And it is.
I need something to drink.
Next.
All right, got a good one for you. I hope the whole thing isn't going to go like this. It's going to get the Tylenol when I get home. What happens to the radiation pattern of an unterminated long wire antenna as the wire length is increased? A, the lobes become more perpendicular to the wire.
B, the lobes align more in the direction of the wire.
C, the vertical angle increases.
Or D, the front to back ratio decreases. What happens to the radiation pattern of an unterminated long wire antenna as the wire length increases? So this is a piece of wire. And I'll make it longer. I don't think it's going to be a front to back ratio thing changing. And that's not going to change the vertical takeoff angle. So it's either going to be A or B. The lobes become more perpendicular to the wire or align more in the direction of the wire. The wire's getting longer. I'm going to say it's B.
Yeah,
the lobes align more in the direction of the wire. So
just kind of got to
follow
it,
along
seems
the
like.
wire. Yeah. So it seems right. We probably both missed it.
Probably.
What are they saying?
But if we did, a lot of other people missed it too, so we're in good company.
They're saying B in the chat room. We were in good company. Which of the following is a type of OCFD antenna? A, a dipole fed approximately 1/3 the way from one end with a 4-to-1 balun to provide multiband operation.
B, a remotely tunable dipole antenna using orthogonally controlled frequency diversity.
Well, that sounds like a bunch of inclusion stuff there, doesn't it?
Yeah, it does.
B, a folded dipole center fed with 300 ohm transmission line.
Or D, a multiband dipole antenna using one-way circular polarization for frequency diversity. Not sure what I said the other time. This is gonna be A. I already know this because I've built several of these myself before. Which of the following is a type of OCFD or off-center fed dipole antenna? That's going to be A dipole fed approximately 1/3 the way from one end with a 4-to-1 balun to provide multi-band operation. It works pretty good. It's Probably my favorite antenna.
That's your only antenna.
But that's why it's my favorite.
Okay.
But actually, it's a pretty good performer.
I got one too out here in the backyard. Yeah, I'm going to agree with you. It's A. The chat room, they're all saying it's A. Of course, Tom said B sounds like a word salad, and it does.
It does.
I'm not even sure what that could mean. But it's A.
Yeah.
Here.
I was pretty, okay, I'll take
We
it.
could
I
see
was
that.
pretty confident of that one.
Yeah, me too. That's
The plans for the one I had called for a 6-to-1 balun.
We've talked about that antenna a lot of times.
Mm-hmm.
OCFD's off-center fed dipole. I don't know if we said that or not.
I did.
You did. Okay.
What is the effect of adding a terminating resistor to a rhombic antenna? A, it reflects the standing waves on the antenna elements back to the transmitter.
That would seem unfortunate.
Yeah.
B, it changes the radiation pattern from bidirectional to unidirectional.
C, it changes the radiation pattern from horizontal to vertical polarization.
Or D, it decreases the ground loss.
I'm glad you got this one.
What's the effect of adding a terminating resistor to a rhombic antenna?
Although I think there's only one logical answer there.
A, it reflects the standing wave on the antenna element back to the transmitter. You wouldn't want that.
No, that's not a desired effect.
No, you wouldn't want that at all. B, it changes the radiation pattern from bidirectional to unidirectional. C, it changes the radiation pattern from horizontal to vertical polarization. I know it doesn't do that.
Mm-hmm.
D, it decreases the ground loss. I'm thinking it's B or D.
I would agree with that much.
I'm going to say it's D. Yet that caught you by surprise, didn't it? I saw you.
It did catch me by surprise because I looked in the chat room since it's not my...
Oh, they're all saying it's B.
Yeah. But I honestly thought it was D too. So I don't know. Let's see. When I said that it's only one logical answer, that's the one that I thought was the logical one. So I'm probably completely wrong.
All right. Yeah. That's probably going to be a record buzzer night tonight. It is B.
Wow.
Yep.
Those guys don't miss much, man.
They don't.
Guys and ladies, if there's some out there, whoever, the chat room doesn't miss much.
And it would make sense that changes the pattern from bidirectional, which would be the front and the back, to more of a unidirectional, more toward the front, more toward the resistor. See how those big lobes pointing that way?
Uh-huh.
That is an interesting antenna. It's a big antenna, too.
Is that one like they had at the Voice of America place out there?
Yep.
Crosley?
They had Clyde Hanley built a re-entrant rhombic antenna. Instead of that resistor, you can put a stub in place of it.
Oh, yeah?
And what it does when you put that stub in there is it causes that power with the resistor, the power is just soaked up in the resistor. Okay, I mean, that's what a resistor does. It just radiates heat out. But if you put a stub in there to tune it with, then that's going to cause reflected power to go back in the direction of the transmitter, but it doesn't go to the transmitter. It's got the right phase to add it back to what's being radiated.
Well, then that's almost kind of what that other A option on there was talking about, putting the radiating back to the transmitter.
But it's not really back to the transmitter.
Right.
It's going that direction, but it aligns what's being reflected back with the pattern that's going forward.
Yeah. Youth on the Air Camp 2024 application periods opened. Applications are being accepted for campers interested in attending Youth on the Air Camp Licensed amateur radio operators age 15 through 25 who want to attend are encouraged to apply online at youthontheair.org. The camp scheduled to take place July the 7th through July the 12th of 2024 at the Mount St. Vincent University campus in Halifax, Nova Scotia, Canada. Oh, that's be an awesome place to go. Anyway, this post is kind of long, but for details about the camp, visit the website at youthontheair.org. And for additional information, you can contact Camp Director Neil Rapp, WB9VPG, at director@youthontheair.org.
Check it
That's
out.
cool stuff. Nova Scotia, I always wanted to go there.
Searching for the perfect holiday gift? This holiday season, make your gatherings merrier, your message clearer, and your connection stronger with ICOM. Whether inside the ham shack or on the air in the great outdoors, ICOM has what's at the top of your favorite ham's wish list. The ID5100AD is innovation and mobility taken to the next level. Designed from user input, the ID5100AD offers an intuitive user interface experience with an industry-leading touchscreen display. This radio is one of the most advanced dual-band mobiles on the market today. The ID52A is a VHF-UHF dual-bander with D-Star and FM dual functions and is the first handheld amateur radio with a full-color 2.3-inch waterfall display. The new ID50A gives hours of fun and enjoyment working your favorite bands. Easy D-Star settings, band scope and waterfall display, voice messaging, share picture function, and it uses the same optional accessories as the ID52A, ID51A, and ID31A. Explore the world of microwave with ICOM's new SHF portable, the IC905. This all-mode rig covers 2 meters through 70 centimeters, 1.2 gigahertz, 2.4 gigahertz, 5.6 gigahertz bands, and with the optional CX10G transverter, 10 gigahertz. Aim higher and enter the world of SHF. The IC7300 is a high-performance, innovative HF transceiver with a compact design that will far exceed your expectations. This is the radio that changed the way entry-level HF was designed. The real HF fun starts here. For the mobile and outdoor aficionados, ICOM's IC7100 is road ready. At home or wherever you roam, happy holidays from ICOM. For more information about ICOM's amateur radios and to locate a dealer, visit icomamerica.com/amateur. Why don't we give something away?
How about the shirt off my back?
There you go.
Actually, we'll get you a clean new one, brand new one. A nice ICOM Ham Crew t-shirt. Let me see. Yeah, looks like this. Back looks just the same, if you don't believe me.
Look at there.
So, anyway, nice shirt.
Who wouldn't want one of those, especially for free,
I know, right?
with other stuff in the box?
How can
From
they
Jesse.
get one?
How can they get one? It's very simple to get one of these. Doesn't take, very little effort. Just send us an email, hamcollege@AmateurLogic.TV. You can just send us your name.
Everybody's got one of those.
Yeah. You got to have a name, and you don't have to have a call sign, but you do have to have an email address to be able to send it.
Yeah, pretty much everybody's got one of those too now.
Yep, and a name as well.
Yeah, so you're qualified.
Yep.
You don't have to be a ham.
So why wouldn't you enter? You can put a message in there if you want to. As a matter of fact, this month's winner did put a message in
Cool.
there. He said, please do the general radio operators class next.
Oh yeah.
Yep. So I don't know. We're talking about
Yeah,
it.
we thought about that. We
Yeah.
might do that. We'll see.
Yep. We'll see. We got a little while to.
We survived
Think
this
about it.
antenna
Yeah.
thing.
Oh, and who was the winner?
Yeah, that's a good question.
It's David Hold,
Oh, okay.
KE5ZZO, and I'm not sure if he's in there tonight or not. I haven't been able to keep up with the chat room between missing all these questions.
I know he's been around for a while. I remember his
Yeah.
remember his name and call.
Yep. Congratulations, David. You're this month's winner of a ICOM swag package
Yeah.
featuring an ICOM t-shirt.
Yeah. So Jesse will get in touch with you, get
Yep.
your information, and get it to you.
So the rest of you watching, just drop us an email, hamcollege@AmateurLogic.TV. It would really help the dean out here.
I know, right?
Yeah, it helped the professor out as well. You could even put a note in there like David did. Why not? It's not a record. We've missed this many before.
Well, you got 2 so far, and I got 1. That's the first time I remember you being 2 up on, or 1 up on.
Yeah, you're going to have to catch up.
Don't worry, I'm working on it. I may even pass you. This might be my evening.
By all means, come on, bring it on.
Yeah.
Who answered the last one? I got the last one wrong, so you can get this one wrong. What is the approximate feed point impedance at the center of a 2-wire folded dipole antenna? A, 300 ohms.
B, 72 ohms.
C, 50 ohms.
Or D, 450 ohms. I don't think it's 72 ohms. What approximate feed point impedance at the center of a 2-wire folded dipole? I think that's A, 300.
Okay.
I think. It's either D or A or D. It's not 50 ohms. It's certainly not 72 ohms. I'm pretty sure it's A.
All right. Well, most people are saying it's B.
Really?
Yep.
Well, it probably is, and then I probably just got caught up with you. So,
Well, no,
I've already said A.
I don't think you got caught up. I think it is A. Let's see. It is.
All right, here's one for you. What is a folded dipole antenna? Oh, that should be a fairly easy one. Maybe. A dipole 1/4 wavelength long.
B, a type of ground plane antenna.
C, a half-wave dipole with an additional parallel wire connecting its 2 ends.
Or D, a dipole configured to provide forward gain. What is a folded dipole? A dipole 1/4 wavelength long? No, that would just be a dipole. Well, that'd be a very short dipole because they're usually a half wavelength.
It's still a dipole.
Yeah, but it's not folded.
Nope.
A type of ground plane? No, it's not a ground plane. C, a half-wave dipole with an additional parallel wire connecting to its 2 ends. C. I'm going to say it's C. Chat room, they're saying C. That's really the only one that, to me,
Seems right.
yeah.
Yeah, I think it's C.
And it is. I actually have a drawing here. That's what a folded dipole is. Feed line goes in the bottom there. You got a traditional half-wave dipole, 1/4 wavelength on either side. And then you got another wire that connects the 2 ends together. And that's why it's folded, because it folds back over.
Then my definition I've had in my mind has been wrong for years. Because I actually thought it was where the ends folded over instead of connected back together.
Which of the following describes a G5RV antenna? A multiband dipole antenna fed with coax and a balun through a selected length of open wire transmission line.
B, a multiband trap antenna.
C, a phased array antenna consisting of multiple loops.
Or D, a wideband dipole using shorted coaxial cable for the radiating elements and fed with a 4-to-1 balun. That's going to be a multiband dipole antenna fed with coax and a balun through a selected length of open wire transmission line.
That's what everybody's saying in the chat room, and I think my first HF antenna was a G5RV, and I think a lot of folks' first HF antenna was a G5RV. And then they got something, I won't say better, but some people will argue with
Something that didn't radiate back down the feed line so bad.
Well,
I
that
remember you had a bad problem with
yeah, I
that.
did. And I had it up as a sloper too because that's the only way I could fit it in the backyard.
Mm-hmm.
That doesn't work good. I had a lot of noise picked up with that. But yeah, I'm going to agree with you. It's just a dipole with ladder line coming down a certain length, and then you hook your coax to there. It says through a ballon. I don't think mine actually had a ballon. I think it had a little thing looked like a ballon, but it was just a straight
Like a little
through.
choke.
Wasn't even that. It was just something to hold a.
Well, that's probably why you had all the radiation problems then.
Yeah, it could have been. You got one for me?
I got one for you. It's a good one too. And I'm really glad this one is yours. Which of the following describes a ZEP antenna? A dipole constructed from zip cord.
That would be too easy. B, an end-fed dipole antenna.
C, an omnidirectional antenna commonly used for satellite communications.
Or D, a vertical array capable of quickly changing the direction of maximum radiation by changing phasing lines. Well, I'm going to throw out the dipole constructed as zip cord.
Oh, you don't think that worked too well?
I don't think that's it. I'm thinking zip and zep.
Yeah.
I think that's a trick question there.
I think you're right.
I don't think it's C, an omnidirectional antenna commonly used for satellite communications. This is an HF antenna. D, a vertical antenna capable of quickly changing the direction of maximum radiation by changing phasing lines. It's not really that complicated. A zip antenna is just an end-fed dipole. It's B. That's what everybody's saying in the chat room.
Well, I did not know that.
Now, what would you have said?
Actually, I probably would have guessed that one because I don't think it's a vertical array capable of quickly changing maximum radiation. The word in the extra class stuff, right? Most of it's HF stuff. I don't think that's it. I don't think it's A or C either. So I would have probably narrowed it down to B.
Okay.
Just because of that.
Just because.
Just because. That's what I used to tell my mom. Tell me, why'd you do that? Just because. Never went over too well there either.
And Mike says, which of the following answers best describes a word salad? Yeah, I'm going to say D.
Yeah.
How is the far field elevation pattern of a vertically polarized antenna affected by being mounted over salt water, or seawater actually, versus soil? A, the low angle radiation decreases.
B, additional higher vertical angle lobes will appear.
C, fewer vertical angle lobes will be present.
Or D, the low angle radiation increases. How is the far field elevation pattern of a vertically polarized antenna affected by being over seawater versus soil? The low angle decreases. Additional higher vertical angle lobes will appear. Fewer vertical angle lobes. Low angle radiation. I think it's D. Because I think the low angle radiation would decrease over the soil, but it seemed like it would increase over the water. What's everybody saying? D.
They're all saying D.
Yeah, I think that's right.
That's what I'm saying. There you go. It is D.
Okay. That would make sense to me.
Yep. You know, we all hear that if your antenna's sitting over water, it works a lot better.
Mm-hmm.
It's seawater or salt water.
Yeah.
Regular fresh water doesn't have that big of effect.
Seemed like it would have some.
Not that much.
Enough of, if it was a big enough body of water.
Yeah. you would think, but no, I've read
So,
that it really it doesn't
interesting.
have that big a change. I can tell you though, it changes it does change some stuff because I was talking earlier about that 3-tower directional array.
Mm-hmm.
In the summer, when it gets real dry, the reflected power goes up on the transmitter, and
Oh,
those readings that I measure on the phase monitor change a little bit. In the winter, when it gets wet, reflected power goes back down, and the readings change. You know, the
because the
phases and the
ground
power.
conductivity.
Yep. Yep.
Yeah. Which of the following describes an extended double ZEP antenna? Well, you got the ZEP stuff tonight. A wideband vertical antenna constructed from precisely tapered aluminum tubing.
B, a portable antenna erected using 2 push support poles.
C, a center-fed 1.25 wavelength antenna or 2 5/8 wave elements in phase.
Or D, an end-fed folded dipole antenna. Which of the following describes an extended double ZEP antenna? Well, it's not a vertical antenna, so I'm going to rule out A. And it's not made with aluminum tubing either, so we can strike A out. B, a portable antenna erected using 2 push support poles. No, it's no, I don't think so. D, an end-fed folded dipole antenna. I'm not sure an end-fed antenna could even be a dipole. Di means 2, doesn't it? I think it's C, an end-fed 1.25 wavelength antenna, or actually it's like 2 5/8 waves antennas in phase.
Which one did you say it was?
C.
C. Well, I can't wait to see what the answer is because we got mixed responses in the chat.
We do, so it could go either way here. I'm going to stick with C.
Okay. Well, that's one I would have thought too because of the 2 5/8 waves and elements in phase.
5/8 waves make good antennas as far as the
Oh yeah.
angle of radiation coming off of them. So, yeah. Actually, I would like to try that antenna. I don't have enough room here, but I do up at the farm.
Yeah.
So
Oh yeah, that'd be
I may
great.
try that one
See if
day.
you can get one up there before field day.
Yeah. Well, let's see. How does the radiation pattern of a horizontally polarized 3-element beam antenna vary with increasing height above ground? A, the takeoff angle of the lowest elevation lobe increases.
B, the takeoff angle of the lowest elevation lobe decreases.
C, the horizontal beam width increases.
Or D, the horizontal beam width decreases. I knew that was coming. You got a pattern there. How does the radiation pattern of a horizontally polarized 3-element beam vary with increasing height above ground? I don't think it's C or D. I think it's going to be A or B. And if you're increasing it, takeoff angle of the lowest elevation decreases. Unless I'm thinking about this completely wrong in my head, and I probably am, I think it's A. What?
Okay.
Oh, I got some E's on here.
Yep.
There's also a lot of B's, so it's probably B.
Oh.
Yeah, I just got it wrong in my head.
All right. It's a tie ball game.
Anybody's game now.
Yeah.
How does the performance of a horizontally polarized antenna mounted on the side of a hill compare with the same antenna mounted on flat ground? A, the main lobe takeoff angle increases in the downhill direction.
B, the main lobe takeoff angle decreases in the downhill direction.
D, the horizontal
Beam width.
Yeah, the horizontal beam width increases in the downhill direction.
Was that C?
Yeah, that's C. The horizontal beam width decreases in the downhill direction.
D, the horizontal beam width increases in the uphill direction. All right, I'm going to throw out the horizontal beam width stuff there. I don't think it's either one of those. I think it's going to be the main lobe takeoff angle going downhill. Seems like to me it would decrease. The antenna's going down. Yeah, so I'm going to say B. That chat room's saying B.
Chat room's right.
Yeah, I really didn't need to miss another one right there.
It would have been okay with me.
Yeah. I can see. I can see that.
Was that it?
That's it.
So it's
that
tied
was-
up.
That was 14 questions. It was a tie ball game.
That was your last Hail Mary too, man. You could, if you brought that one all the way home, you would have won. You'd have had 3.
I guess we got to go into extra innings now.
That's all right. I think I've had enough innings.
I think I have to.
Well, it was interesting. I learned a lot again. I learned something on every one of these.
Yeah,
Maybe I relearned some of it.
if you sat down with some graph paper and a pencil and you really thought real hard, if you didn't go to sleep, you would probably, you could see how some of this stuff works.
Yeah.
You know, it's coming up holiday season here.
Yeah, it is. It'll be here before you know it.
We're shooting this on the 1st of December. So we're going to have a Amateur Logic Christmas show coming up very soon. You hear that, Mike? An email? I don't think any of us have done anything toward that episode yet.
Yeah. No, I haven't. I just figured out today what I'm going to have for a segment.
So we're thinking December the 15th.
Works for me. It's either that or next Friday, and that's awful close.
Yep.
And Tom said he can't wait to hear the new Christmas album.
Me neither, you know.
Yeah.
It's going to be hard to top that Rock and Ray performance.
Yeah.
But it's about time. You know how these artists, they'll have a hit and then they'll go away. You won't hear
it's like
from
a
them.
one-hit wonder.
Yeah, until they get retirement age, and then they've got to release some more material.
Because they run out of money?
They're running out of money.
I understand how that could be.
So maybe Rock and Ray can bring out another hit there.
Yeah, maybe. I don't know. You have to call him and see if he's up for it.
Yeah.
See if he's still got any money left from the last hit.
We're going to have to check the contract. He may owe us one.
That had to be the funnest Christmas show we've done in the 18 years.
It was one of the funnest.
Yeah, they're all pretty good, honestly. But that was pretty creative. I got to say,
there's a couple that stick out in my mind, and that is one of them.
Yeah.
So this month, or actually, it is this month. This year, we got a few good ideas out there. They've got to be polished on a little bit and actually put down digitally. You know, this time of year would be a good time as well if you'd like, because people like to do social stuff around Christmas and the holiday season. This would be a good time for that. Where could you do such things?
Well, we're pretty social people. Well, somewhat.
Sometimes.
We have social places. Facebook.com/group/hamcollege.
You can follow us at Ham College on X, or formerly known as Twitter.
Yeah. And we are on groups.io, groups.io/G/AmateurLogic. We don't have a separate group for Ham College for that one.
No, but that's where you can find out what's going on. And this time of year, if you got a little spare time on your hands, why not drop in there and post something, share something you've learned with us, and all the other viewers.
Hey, I got some ham friends too that I'd like to get some ham gifts for some, maybe some cool shirts or something like that, or some mugs. Where can we find some of those?
You know, you can't find them tonight because there were so many questions. I run out of places to put pictures.
But I bet you if you went to Spreadshirt, no, they changed it. AmateurLogic.com, no. Where is it? Spreadshirt.com/AmateurLogic.
You're going to make me look.
I should remember it. They messed me up and they changed the URL
Yeah.
of it.
Apparently, you cannot get there from here.
Okay, so well, you better send your thing in so you can get an Icom
Here
Crew
you
t-shirt
go.
then. Yeah, shop.spreadshirt.com/AmateurLogic for all your Christmas shopping needs.
Yep. And if you had questions, it could happen. You're wondering what was on a particular episode of Ham College or Amateur Logic, you could find that out at the AmateurLogic.TV/wiki site.
Yep. I know a guy that puts that stuff on there every month.
Yep, I do too. I guess that's going to do it for tonight.
Yeah, ready to
Unless
find
you got
some
something
supper.
else.
No, supper time.
It is. Yep,
It was fun. It's tough, but it was fun.
it was. Well, thanks for being here. Join us on the 15th for the next Amateur Logic, the 2023 Christmas extravaganza. You
Yep.
don't want to miss it. And the end of the month for the next Ham College.
Yep, looking forward to it, I think.
7-3.
7-3, everybody. I started to do the Vulcan.